Hello and welcome back. Mr. Wakefield here looking at section 3.4. This section is going to come in a couple different parts here, a number of worksheets in fact. If you go through your worksheet packet, I sent you the current worksheet packet. There's a number of sheets for this. And it's all the first part of 3.4. The reason why there's so many different things to look at is because it's really important to get off to a good start here with the bigger word problems that we're going to do instead of trying to jump into the actual problems themselves. We're going to look at some things right here, some smaller problems that are going to help us with the bigger problems. In other words, these problems that we're going to be doing in these next couple of sheets here in this current video are going to be things that you'll see as a part of some of the bigger problems in the next video. All right, so we don't want to go too fast by jumping into those bigger problems right away. Okay, we want to look at some of the smaller pieces of those problems so that we'll be more prepared for those bigger problems when we get to that next video. Okay. So, because, word problems can be challenging for a lot of students. That's completely understandable. So we want to go through this slowly but surely, all right? So one of the big things about word problems, at least the ones in the next video more than anything, but even the ones after that too, is that one of the big challenges that students have is translating the words, the phrases, from English over here to in mathematical form. And we know what mathematical form is. It's when you got variables and constant numbers like 5, and you got some operations like addition or subtraction, multiplication, you got some division down here, okay, that kind of stuff. You could even see some exponents, all right. Those are operations, all right. But that's what the mathematical form is when you translate the English to variables, constant numbers, and operations. Okay, as I mentioned in a previous video, when we eventually set up the equation and solve it for a word problem, okay, we can't have any words inside of the equation, so it's very important that we're able to translate the words into mathematical form. All right, now we have a lot of phrases here, but the good news, and we do need to know these phrases about how to translate them, that is, but the good news is that a lot of these are phrases that you're going to recognize if you have a strong understanding of the English language. Okay, and don't feel bad about asking me any questions, like if you're uncomfortable about any of the phrases at all. All right, I know some of you may have learned the English language more recently. That's fine, okay, but just let me know if you have any questions, all right, because I don't want the English language in any kind of way to hinder your ability to do these problems. So let me know if you have any questions about that, and I'll help you however I can. We do need to have that. We do need to have some basic understanding of the English language, and I know you all do. So that's the most important thing. Okay, But my point is that if you do have a decent understanding of the English language, most of these are going to be things that you can translate just without even looking at this video. You'd still be able to translate it, okay? But some of them are a little more tricky, and so I need to make sure you know all of them by going through each one of these one at a time, okay? But most of these I think you'll be familiar with. So it's not going to be as hard as doing all of these things and learning all of these things separately, okay? But some of these you're not going to recognize as much, or some of them are tricky as well. I'll point those out, at least the ones I think are tricky, but just make sure you know how to translate all of these different things, okay? And, of course, let me know if you have any questions. 5 added to a number. All right, what I'm going to do here, just for the sake of argument, whenever you see the word number, we're going to translate that to X, just to give it a name, okay? Because you know that when we translate something from English to math in a word problem, okay, eventually we're going to have a variable in there. Doesn't mean that the word number will always be X, but just for the sake of practice here, we'll use the letter X to represent that word number. Okay, so 5 added to X, it's just like it sounds. Again, that's one of the ones where you probably already knew what that meant. All right, 5 added to number 5 plus the number 5 plus x. Okay, the reason why I wrote down x plus 5 is because it really doesn't matter whether you say 5 plus x or x plus 5, all right? It means the same thing because when you add two things together, okay, it doesn't matter what order you put them in, right? As long as the sign in front of each term is the same, no matter what order you put it in, okay? And they're both positive, and no matter which way you write it, so it's fine. Okay? 6 more than a number. All right? That's an interesting one because the phrase more than, okay, when I was younger anyway, I don't know about you, but when I was younger, and when I thought of more than, I just thought of it gets bigger, right? Okay, which means, and a lot of students, including maybe myself when I was younger, when I think of something getting bigger, I think of two things in terms of math. I think of addition, but I also think of multiplication. And so more than, does it mean addition or does it mean multiplication? All right. Obviously over here it says addition, but let's find out why. A lot of times when I'm not 100% sure of what some of these phrases mean, I'll relate it to something that I already know from a real life situation outside of a math class, and it'll help me be more certain about it. For example, money. We all can relate to money, right? Okay, like for example, if I said, I've got $10, and then I told you that the next day I'm going to have 6 more than I did the previous day. So if I've got $10 and then the next day I'll have 6 more, how much do I have now? Do I have 10 plus 6 or do I have 10 times 6? Well, it's going to be $16, right? Okay, if I have 6 more than I did the previous day, then 10 would become 16, wouldn't it? All right, so that tells you, and it tells me, makes me more certain, if I'm a student, that more than means plus. Okay, so more than means plus. I'm just showing you this example just to make you more confident about that by looking at money, which is something we can all relate to. All right, we can see that more than is referring to plus. It's referring to addition. Speaking of that, and so that's why this is actually 6 plus x. All right, but again, that's the same thing as x plus 6. You could write it either way. 6 plus x is perfectly fine. All right. The next one here, it says a number increased by 2. Again, let's say that you make $20 an hour at your job, okay, and your boss says, I'm going to give you a $2 raise. In other words, I'm going to increase your salary, your $20 salary. I'm going to increase it by 2. All right. Are you now making 20 plus 2 or 20 times 2? Okay, well, it'd be nice if you were making 20 times 2. That'd be a lot more money. But the truth is that if you get a $2 raise, your salary is going to go from 20 per hour to $22 per hour, correct? Okay, and so that, again, makes me more certain, and I hope it makes you more certain as well, that increased by, that phrase increased by means plus. And so x for number plus 2, and there you have it right there, x plus 2. Okay, now the next one here is actually a part of 4 different types of phrases here that have a similar thing going on with them, and so I want to mention them all at once here. This one where it says the sum, this one where it says the difference, this one where it says the product, and then this one down here where it says the quotient. Okay. All 4 of those things, you guys, have a similar structure to them. All 4 of those phrases that I highlighted with the star next to it have the word and somewhere near the end of the phrase. Okay, you can see it right here. The word and then and here. Okay, that's where the operation goes. And when I say operation, I mean addition, subtraction, multiplication, or division, or exponents, or whatever. Those are operations. And so the word sum means addition. That's just something you're going to need to remember if you didn't know that already. The word sum means addition. The word difference means subtraction. Okay, you can see that here. And by the way, when I was a student, I was thinking, why does the word difference mean subtraction? I just want to make this easier for you to remember. The reason why the word difference means subtraction, think of it this way. I've got $8. You've got $3. Okay, I'm just an example here. What's the difference between what I got and what you got? What's the difference between 8 and 3? There's a difference of 5, right? There's a $5 difference between those two numbers, correct? It's not a coincidence that 8 minus 3 is 5. And so that's what helps me remember anyway, that the word difference means subtraction. All right, if you're looking at two numbers, you say, hey, what's the difference between those two things? All right, well, there's a distance of $5 between there. In other words, there's a difference of $5. All right, and so it's because I subtracted that I got 5, and so it makes sense then that difference means subtraction. So sum is addition, difference is subtraction. Product means multiplication. I don't have a nifty little way of helping you remember that. You just need to remember that, okay? Product means multiplication. And then quotient, again, that just means division. You just need to remember that, okay? So remember what those 4 words mean, all right? Sum, difference, product, quotient, okay? So because sum means addition, what you do is you put the plus sign right here, okay, where the word and is located. That's what I meant with the word and. That's where the operation goes. So that's why it's x plus 4. It's because you put the plus here. Just like on when it's different, you're going to put the minus sign where the word and is. And so you can see that here, x minus 10. Number for x, and then the word and, that's where the minus goes, and then the 10. That's how you translate that. It's going to work the same way for product and quotient. Okay, x times 3, because product means times. X times 3, that's equal to 3x. And finally, quotient, x divided by 8. And you can see I wrote that there, x divided by 8. By the way, I want to clear something up here. All right, when you are doing division and you're actually translating these things, remember these things are going to go in an equation, all right, eventually at some point in your word problem. And we never have the division symbol. Okay, we all know what this division symbol is right here with the 2 dots and the line in between it. Okay, you don't use that inside of an equation. That's just not something that we do. All right, but we do see fractions inside of equations. We've seen a number of problems this semester that have fractions inside of equations. And so what I want you to do, if you have to translate division, you guys, use a fraction bar instead of the division symbol with the 2 dots and the line. Okay. So that's why I said x over 8, x divided by 8, okay? Remember, it's always the top divided by the bottom, all right, in that order, okay? So don't write the x on the bottom. So x divided by 8 means x on top, 8 on the bottom, in other words. All right, now let's go back to the some of the things that we haven't looked at yet up here. Next one here was 8 subtracted from a number. This is where things get a little more tricky. The phrase subtracted from and the phrase less than. Those are the tricky ones, the most tricky ones of all. All right, they both mean subtraction, but here's the thing. Look at what I wrote down here. It says right here 8 subtracted from the number, so you would think that that would be 8 minus x, right? It's not. Okay, it's x minus 8. And that is not the same thing as 8 minus x. The reason why I know it's not the same thing is because, as I mentioned earlier, you're allowed to reverse 2 terms around as long as the signs are the same when you reverse them around. Well, this one right here has negative 8 and positive x. This one has positive 8 and negative x. They're not the same thing. And so this is the right answer, but this clearly is not the same answer that this one is over here, so this must be wrong. But how could it be wrong if I just translated it right off of the page here? It's because subtracted from, that phrase right there, you guys, means that you reverse around the 2 things that you are subtracting. All right? So, for example, let's say that you have a really great job, okay, and you're making $40 an hour. And your boss says, I'm sorry, I need to give you a cut in pay because for whatever reason, maybe they're laying off some workers, okay, and you don't want to be one of those people, so you say, okay, I'll take a cut in pay in exchange for being able to keep my job, all right, and so your boss says, okay, I will take $6 and I will subtract it from your current salary of $40. Okay, so I'm going to take $6 and subtract it from your current salary of $40. How much are you making now, you guys, if your boss did that to you? Okay, wouldn't it be $34? All right, but if I did this, if I translated this in the same order that you see written here, it would be 6 minus 40, wouldn't it? What is 6 minus 40 equal to? It's equal to negative $34. Okay, we don't want negative $34. No. We want $34. And so my point is that subtracted from, you can see here from this money example, again, I'm using a money example to help us understand, all right? This money example helps us realize that subtracted from means that you reverse it. So the two things that that you're talking about when you use the phrase subtracted from, the two things that they're subtracting, they need to be reversed when you actually translate it to math. It's still subtraction in the middle, but you got to reverse the two things. And so that's the reason why 8 subtracted from x is going to be x minus 8. Same thing with less than. Less than's the same way. All right. Let's say that you've got that $40 salary again, and you've been working at the company for a couple of years, and then all of a sudden this new guy comes along, and he's just got started there, so he's making what? He's making $4 less per hour than you are. So he's making $4 less than your $40 salary. Okay? And does that mean that he's making 4 minus 40? We know that less than means subtraction. All right, but does it mean 4 minus 40, or do we need to reverse that one around too? Well, you tell me, okay, at least in your mind, of course. You tell me what this means here. Ask yourself, okay, isn't this going to be equal to 36? If you make 40, then the new guy is going to be making 36, right? But isn't 36 the same thing as 40 minus 4? It's not equal to 4 minus 40, right? Because 4 minus 40 would be what? It would be negative 36. But no, the new guy's making 36. So, again, very important. Underline these things to remind you. Put a star next to them. All right, these are the two trickiest ones on the whole page. All right, subtracted from and less than. Those are the ones where you take the two things and you reverse it around, okay, with the minus sign still in the middle. All right, so 4 less than a number, x minus 4. It's not 4 minus x. All right, so those are the two things you reverse around. Now, there are other things, such as decreased by and the difference. Those things, you don't change the order. So you don't always change the order when it's subtraction. It's just on these two that you do that I underlined here. All right, so a number decreased by 6. If you have a $40 salary, and again, your boss has to decrease it by 6, it's going to be 40 minus 6, not 6 minus 40. So in this case, it is going to be in the same order. All right, so decreased by, you do not change the order. Same thing with difference. You don't change the order. All right. The only time you change the order is with subtracted from and less than. All right, now, a number multiply, and by the way, you could change the order up here as well just because it doesn't make any difference, all right? I'm not saying that there aren't other times when you can change the order, but only if it still ends up being equal to the original order, all right? If you change the order on these two, subtracted from and less than, as I pointed out earlier with the 8 minus x over here, it's not the same answer, okay? So those are the ones where you must change the order, otherwise you'll get the wrong answer. That's the thing. All right. But there are some other ones where you could change the order, but only if it comes out the same as the original order. And that's the important thing to remember. A number multiplied by 12. We know that that's x times 12. Okay, but we also know that x times 12 is 12x. Again, you could change the order, right? All right, and we do that all the time when we do x times 12, all right, because we know that multiplication, the order can be changed. Just like 3 times 5 is the same thing as 5 times 3, all right? X times 12 is the same thing as 12 times x, All right. The product of a number and 3, we talked about that already. Okay, but let's do it again here in this specific example. X times 3 is the same thing as 3x. All right, twice a number. Okay, if I make twice what you make at a job, all right, that means I make 2 times as much as what you make. All right, so that's why this says 2 times the number, 2 times x. These next two here have a fraction and a percentage followed by the word of. And as it mentions down here in parentheses, all right, when you have a fraction or a percentage followed by the word of, okay, that means multiplication. All right, fraction or a percentage followed by the word of. I'm just talking about a fraction and a percentage there, not regular numbers necessarily. Okay, now, so that's why it says 1/4 times x, because the of means multiplication. Now, the deal here with the percentage, you don't ever, percentages, you guys, are just like those division symbols. We don't ever want to have a percentage or a division symbol. Okay, don't put either one of these in an equations. All right, don't put in equations. All right. So what we do, we already know what we do with the division symbol. The division symbol, we use a fraction instead. We talked about that a few minutes ago. All right, but what do we do with percentages? Well, percentages, by definition, mean divided by 100. When it says 14%, you guys, that means 14 divided by 100. That's the reason why when somebody says, hey, 14% of the people are going to be doing this activity, all right, this certain activity, that means that 14 out of 100 people are going to be doing it. All right? It's because this means divided by 100. Anyway, so percent means divided by 100. So in order to get rid of the percent, what you do is you convert it to this right here. 14 over 100. All right, and usually, as long as it's not some big weird decimal or something, usually when we do that, we convert that to a decimal by putting it into our calculator. Again, this is when you convert a percent, all right, to the mathematical form over here in a word problem. Usually you convert it to a decimal, okay, and so we're going to do that here. So 14 divided by 100 is going to be, if you put that in your calculator, it's going to be 0.14, same thing as 0.14. So yes, when you have a percentage in a word problem, what you want to do is do the number that's in front of the percentage, divide it by 100, okay, convert it to a decimal, and then that's going to be part of your mathematical form over here. All right. A number divided by 9, that's just like it sounds. Remember, whatever comes first is going to go on top, and whatever goes after the phrase divided by goes on the bottom. All right. And we already talked about this one here. Okay. 1/3 of a number. That's basically the same thing as this one up here where it says 1/4 of a number. It's just that the fraction was written out in words, 1/3. Okay. So it's 1/3 times x. You could also write it like this. Okay. Because if you multiply 1/3 times x, it would be equal to this right here. All right, but 1/3 times x is usually fine as well. And so that's some key phrases right there that you could run into from time to time. What we're going to do down here where it says other key phrases is now we're going to do some combinations, at least for the first few here. We're going to do some combinations. We're going to clear up some potential tricky stuff as well. All right, let's look at the first one here. It says 6 more than twice a number. You can see here that they combine two different things that we've already talked about into one phrase here. More than, which we talked about, that is plus. And then twice, we mentioned up here that twice means multiplication, 2 times. So what this is saying right here, you guys, is it's saying 6 plus 2 times x. All right, 6 plus 2 times x. And yes, you could write it that way there as well, although this is fine too. But you can write 2x plus 6. All right, because again, you can reverse around two terms as long as the signs for both terms are still the same when you reverse it around. And of course, as I've mentioned before, you still got to have a plus or minus in between them, okay, because it's still two different terms. All right, they weren't combined into one, so you still got to have that plus or minus in between it. And so you can see that these two things are the same then. They have the same sign in front of each term when you reverse it around. So either answer is acceptable. Now this next one here is where things get a little bit tricky, and not just because of the less than phrase, because we now know what less than means. But here's the thing. It says 3 less than 5 times a number. Are they asking you to do 3 less than this whole thing 5 times a number? Or are they asking you to do 3 less than 5 to do that first and then times that by the number? Which one are they asking you to do? Well, since this is written in words, there's really no way of knowing without actually establishing what this situation means. All right, so I need to do that for you right now. And I wrote down this note down here. I'll give you a chance to write that down. Let me say what it says here, and then I'll kind of elaborate on it. It says that if you have a phrase that contains only the following 2 operations, nothing else but just these 2, multiplication and then either addition or subtraction. So we're talking about a situation where you either have multiplication and addition, and that's the only 2 operations. No subtraction, no division, no exponents. Or it could be a situation where you have just multiplication and subtraction only, like this problem does, where you less than means subtraction and then times means multiplication. Nothing else. Everything else is a number or a variable. Okay, in one of those situations, you guys, then, unless it clearly indicates otherwise, and I'll show you when it does here coming up, you need to set it up in such a way that the multiplication would be calculated first if you had to plug a number into the variable. Let me show you what I mean by that. Okay, we have normally we would have 2 different possibilities here. We would either do 3 less than 5 first, and we know that 3 less than 5 means 5 minus 3, because less than means you reverse the 2 things that are being subtracted. And then it says times a number. So then we would take that answer 2 and we would multiply it by x. Is this the correct setup? Well, what's the other possibility? The other possibility is to take 3 less than this entire thing right here. Okay, if we do that, then we have to say that this is 5 times x right here, and since less than means you reverse it around, you take 3 and you take 5x, and you reverse them around, and you get 5x minus 3. So the question is which one of these 2 things is the right one? Well, this is telling you that multiplication would come first, would be calculated first, all right? You need to set it up so that would happen, all right? Notice here that I subtracted first, though, and then if I plugged a number into this, that would then you would then do the multiplication after you did the subtraction, because we already did 5 minus 3 equal to 2, all right? And then so if I plug a number into the variable, all right, the subtraction went first to get the 2, and then 2 times whatever you plugged in, that would go second. That can't be right, because it says that multiplication has to go first if you plug a number in. Notice here now that if I plug a number into there, I'm just pretending here, this is not for the actual problem, but just to make sure that I set it up right, if I plug a number in there like 2 into the variable, wouldn't I do multiplication before I do subtraction? Because multiplication is what? It goes before a subtraction in order of operations, all right? But here I subtracted first before I even multiplied it. And so that's why I know that this is the right one, because here the subtraction went first, but down here the multiplication did. All right, so that's why I can be confident that 5x minus 3 is the correct answer, and not subtracting first and then multiplying by the variable, which is the word number right there. Okay. Next one here, 3 times a number increased by 4. Okay, 3 times a number, that's 3x, increased by means plus, so we got 3x plus 4. Again, if you plugged a number into that, all right, since this is just multiplication and addition, this rule also applies there. Okay, 3 times, if you plugged in a number into this, the multiplication would come first here. All right, now you might be thinking, hey, wait a second, I thought multiplication always comes before addition. Isn't this obvious? Now look at the next one here. Here the addition would come first because why? Because the parentheses come before multiplication, and there's addition inside the parentheses. So no, it is not true that multiplication always comes before addition, because sometimes the addition is inside the parentheses, and the parentheses go before the multiplication. As you guys know, PEMDAS, right? As we've mentioned many times this semester, all right, parentheses come before multiplication. Multiplication, yes, multiplication comes before addition, but the parentheses come even before that. So that then brings us to this next problem here. Okay, why is it that even though they mention multiplication and addition here, some remember means addition, why is it that they set it up so that if I plugged a number into this, it would be addition being calculated before the multiplication? Why? It's because, as I mentioned down here, you guys, unless it clearly indicates what? Unless it clearly indicates otherwise. All right? It does clearly indicate otherwise here because it says 3 times what? It does not say 3 times a number like it did up here. It says 3 times the sum. And remember, you guys, the sum, they're talking about this whole thing right here when they say the sum. Remember, the sum, anytime they give you a sum in a word problem, they're talking about 2 things being added together there. That's 2 terms. And when you got 2 terms with a plus in between it, that's 2 different terms. The plus separates it into 2 terms. Okay, so unless you can combine them, and we can't here because these are not like terms, these are 2 terms and they're going to stay that way. And as I've mentioned many times this semester, when you multiply something by a thing that has 2 terms in it, in this case the sum, you've got to bracket that thing that has 2 terms. Okay, if I write it like this, like I did in the last problem right above it there, it looks like you're just doing 3 times x. No, you've got to do 3 times the entire sum. X plus 4, not just x only. And so that's the reason why this is bad, and this is the right answer here. Okay, same thing happens down here. I'll come back to this one in between here in a second. But see how in this one right here, it says 4 times the difference. The difference also has 2 terms, as we saw up here. Okay, when you have the difference between 2 things, assuming they're not like terms, which they're not here, and they won't be in the current problem that I'm looking at either, you have to put a bracket around the difference because it's going to have 2 terms. It's going to be multiplied by something. And so let's review here. That's another couple of problems you really need to watch out for. So be careful of those. In these 2 problems, you got to put a bracket around the sum and the difference because they have 2 terms and they're being multiplied by something. So that's why it says 4 times bracket x minus 2. X minus 2 is the difference, and you need to multiply by the entire difference. All right, now, what about this one in between the 2 stars here? It says 4 times a number. Notice how it says 4 times just a number, not the entire difference. 4 times just a number decreased by 2. Okay, so in that case, you just have 4 times x, and then minus 2 is separate. You're not multiplying by the entire x minus 2, just the x. And so that's why there's no bracket there. You're just multiplying by x. Okay. The difference between 5 times a number and 2. And notice there's no bracket here. You might be thinking, wait a second, I thought when we had times and difference, we're supposed to use a bracket. Not when it's written like this, though. Remember I said that when the difference is being multiplied by something, that's when you use the bracket. Okay, the difference here is not being multiplied by something. Okay, it just says the difference between 5 times what? 5 times a number. We're not multiplying by the difference. We're multiplying the 5 by the x, and that's it. We're not multiplying by the entire difference this time. Okay, the difference between what? There's that word and. Remember, the word and is the key word there when you have the difference. All right, that's where the subtraction symbol will go. So it's just 5 times x minus 2, and that's why you see that right there. Okay. The population of a city increased by 5%. Now, as we said, when you have a percentage, put that in your calculator, 5 divided by 100. Just like the next one here, 20 divided by 100, put that in your calculator. That's going to be, in your calculator, 0.05. And this one's going to be 0.2. All right, you could say 0.20 as well. Remember, you can always put a 0 on the end of a decimal if you want. It's not wrong to leave that 0 out, okay? But you can always put a 0 on the end of a decimal on the right-hand side of the decimal point. It's the same answer with or without the 0, though. I put it there just because this had the 0 here, all right? It just kind of looks more normal that way, but 0.2 is also fine. Okay, so, but when you have increased by a percentage or decreased by a percentage, it's still going to be addition for increased by, as we would expect, based on what we talked about earlier. And then decreased by is still subtraction. And population and cost, again, just for the sake of argument here, we're going to call that x. Both of those are x right there. So we have x plus 0.05. But when you have increased by a percentage, you have to put the x again. Whatever was over here, you got to write that again. That's just how it works when you increase something by a percentage. You don't just write the percentage and what it converts to, which is this decimal right here, but you also got to write the x after that decimal as well. That's just how it works. Same thing when you decrease something by a percentage, you have to you say subtraction because it's decreased by. But you, after you write down the decimal conversion for the percentage, you got to write down the whatever this thing over here was equal to again. So since this thing was x, you write down the x again. All right. So when you increase or decrease something by a percentage, whatever you're increasing or decreasing here at the beginning of the phrase, that has to be written again over here. So if the beginning of the phrase is x, you got to write x again. All right. That's something you see a lot in real life situations as well when they talk about increasing or decreasing something by a percentage. So that's a real good thing to know. The cost, again, I'll call that X again. The cost of purchasing X notebooks. This could be any items that you're purchasing, not just notebooks. Okay, X notebooks at $3 each. If each item costs the same amount, okay, and they tell you how much they cost each, and you want to come up with a phrase that describes the total cost of all of them, then you would say the cost per item times the number of items you're buying. The cost per item, which is $3, it says $3 each, times the number of items you're buying. And so that's 3x. Okay, what I'd like you to do right now, since we're at the end of the page here, is go to the second page, and you can see that there's a bunch of examples there, all right, which are very, very similar to what we just did. Again, be very careful with these ones especially, but all of them, okay, but especially those ones, because those are the ones that have what, you guys? Subtracted from and less than. All right, students more often than not miss those ones more than these other ones here. So I just wanted to give you a heads up here before you try it. All right, so try those problems there. Hit the play button after that. We'll see how they come out, and then we'll look at one more page here. Okay, and number one right there, 8 plus x, right? So you could say 8 plus x. You could also say x plus 8. If you had said x plus 8, you don't need to change it. You did it right. Okay, same answer. All right. The sum of a number and 6. Again, when you see the word sum, you look for the word and that's where the plus goes because sum means plus. So we have x plus 6. Right? Now here's the tricky ones here. 3 subtracted from a number, that's 3 subtracted from x. Subtracted from means you reverse it around. So instead of saying 3 minus x, we're going to say x minus 3. And no, those two things are not the same thing. 3 minus x is not the same thing as x minus 3 because here you have negative 3 and positive x. Here you have positive 3 and negative x. Not the same signs, and so you can't say that they're the same answer when the signs are not the same. All right. Next one here. A number subtracted from 5. Again, you reverse it around, so now it's going to be 5 minus x because subtracted from means you reverse it around. And finally, 10 less than a number, less than, you also reverse it around, so it's going to be x minus 10. The two things that are being subtracted get reversed around, okay, the opposite direction. But decreased by and the difference between, you don't reverse it then, as we talked about. So it's going to be x minus 7 difference between 12 and a number. All right, again, the word and is what you look for when you do difference, just like sum. So it's going to be 12 minus a number, 12 minus x. The product of a number and 5, that is x, and then that's where the multiplication symbol goes. So it's going to be x times 5. All right, but we know that that's the same thing as 5x, as we talked about earlier. 1/6 of a number. All right, when there's a fraction before the word of, that means multiplication for the word of. So it's going to be 1/6 times x. All right. When you have a percentage followed by the word of, that means multiplication as well, where you see the word of. And so that's going to be 27% times x, but we don't want percentages inside of our equation, okay? Which means we don't want it in here either, because these things that we're doing, these translations into math, mathematical form, these are the types of things we're going to put in equations eventually. So anyway, we convert that, as I mentioned earlier, you convert your percentage to a fraction. You don't have to write down the fraction here. You can just put in your calculator 27 divided by 100. But that's what you want to type into your calculator right there. And your answer in your calculator should be 0.27. You could also say 0.27. That's the same thing. All right, so 0.27x. The quotient of a number in 3. Remember, quotient means division. All right, we look for that word and, as I mentioned earlier. So this is going to be x divided by 3. 7 more than twice a number. Here's where we're getting into the ones where we have more than one operation in the problem. 7 more than twice a number. That is 7 plus 2 times a number. Okay, you could either say 7 plus 2x, or you can reverse it around, which is fine because you can see that both of these terms have the same sign in front of each term that this one does. They're both positive. And you still have the plus. You still have a plus or minus separating the terms, in this case plus. And so it's okay to reverse them around in that case. As I mentioned earlier, when you have subtraction and multiplication, all right, it's based on if you just have those two things, and unless it clearly indicates otherwise, which it will in the next problem, you want to set it up so that the multiplication comes first. All right. So we're not going to do 3 minus 6 first, like we did in that other problem where we did 5 minus 3 first. Okay, we're going to set it up so that the multiplication comes first. All right, so that's going to be 3x minus 6. The other option, like I said just a second ago, would be to do the 3 minus 6 first, which would be negative 3, and then you do the multiplication after that. But that's a totally different answer. And so this one right here, 3x minus 6, that's the one where if I plugged a number into the x, the multiplication would occur before the subtraction, wouldn't it? All right, because of order of operations. And so that's why this one's correct and this one is not. All right, the multiplication has to come first unless it clearly indicates otherwise. Speaking of clearly indicating otherwise, in number 14, it says 5 times the sum of a number and 8. It clearly indicates that you got to do 5 times the entire sum, and so we need to do 5 with the bracket around the sum because it's got 2 terms in it. Okay, x plus 8, that's what the sum is. Just like we did on the first page, the sum, you're going to have 2 terms with the plus in between it. That's the x plus 8 part, and then you got to multiply that whole thing by 5. And so that's why this is the correct answer right here. I just moved it over. But this answer right here without the bracket is wrong. 5x plus 8 without the bracket would be wrong. Okay, so even though the addition comes first here, if I were to plug a number into x, the addition would go first. All right, that is not a contradiction to what I said earlier, because I said unless it clearly indicates otherwise, the multiplication should come first. But this is one of those times where it clearly indicates otherwise, because they are clearly saying that 5 has to be multiplied by the entire sum. All right, it's not one of these ones like number 13 where you're looking at it and you're thinking, okay, it's hard to see just by looking at it what you're supposed to do. All right, that's when you follow the multiplication addition rule that I talked about. The multiplication rule of doing that first before the addition and subtraction. That's when you follow that rule that I wrote down in pencil there at the bottom of the first page. The next one here, it says 9 times the entire difference. And so that's why you have to put a bracket around the difference here, because you got to multiply by the entire difference, just like we talked about on the front side of the page. Whereas number 16, it mentions difference, but you're not multiplying the difference by something. So no bracket on that one. Okay, 6x minus 7, because the word and is where you put the minus sign. All right, but you're not multiplying the difference by anything. You're just doing 6 times the number. So 6 times x and then the minus 7 right here. Minus because it's different. Difference means subtraction. The profits of a company, I'll go ahead and call that x. All right. Increased by 18%. Okay, so that is x plus, but remember, you don't just convert the 18% to a decimal, all right? Although we do need to do that too. That's 18 divided by 100 in your calculator. That would be 0.18. But remember, you got to put that x again over there on the other side of the 0.18, just like we did on the first page. Okay, whatever's over here has got to be written again at the end of the decimal there. Same thing here when it's decreased by. The only difference is that it's going to be subtraction because it's decreased. So it's going to be x minus, and then what's your decimal equivalent here? 12 divided by 100 in your calculator is going to be 0.12. And so that is going to be x minus 0.12, and then again you have to write the x again. And finally, the cost of purchasing X burgers, just like the notebooks on the first page. Okay, purchasing them, assuming that they each cost the same amount, all right, you just say 2 times the number of items you bought. Okay, so the cost of each item multiplied by the number of items you bought is going to be equal to the total cost. We're going to be talking about that more here, and when we get into some bigger word problems, you're going to see that that same formula for total cost. You don't need to get too heavily into that right now. Just know that total cost of purchasing this many burgers, all right, is going to be equal to the cost per item, cost per burger in this case, times the number of burgers you bought. Okay, just like with notebooks, cost per notebook times the number of notebooks, cost per burger times the number of burgers. That gives you the total cost of all the burgers you're buying, and so that's why it's 2 times x, and there it is right there. Okay, so that is translating some key, it doesn't mean that all of the key phrases are here that we're going to do, but these are a lot of them. And then if there's any new ones, certainly I'll go over those ones with you carefully. All right, but these are the key ones for now that we're looking at. One last page here that we need to do, and that is, let me pull it out here. This is the third page of the 3.4 section from your worksheet packet. It should say translating English statements into mathematical equations. All right. Basically, this page right here is exactly the same as the first 2 pages. The only difference is that it's equations now. And what did we just do, you guys, in the first 2 pages? What we did was we had all these mathematical expressions here, didn't we? Well, aren't equations mathematical expressions too? The only difference is that you have 2 of them with an equal sign in between it. That's the only difference, okay? If you take any 2 of these things right here, you guys, any 2 of them, pick a pair, okay, and you put an equal sign in between those 2 that you picked, you've just created a normal equation, okay? So when I ask you to translate an English phrase into a mathematical equation, you're going to get, it's a little bit of a bigger problem now because it's going to be 2 of them now with an equal sign in between it. Which then begs the question now, how do I know what English phrase is going to give me an equal sign? How do I translate that? Well, let's take a look at some examples of something that equals that is the same thing as an equal sign. Okay, what are some English phrases that when you translate it, it's an equal sign? If I said that my salary is $20 an hour. Doesn't that mean that my salary equals $20 an hour? Okay. So same thing here. 5 times the number is negative 50. That means that 5 times the number equals negative 50, right? Okay, so the word is usually means, not always, as we'll find out here, but it usually means equal. Okay, if there's mathematical stuff on each side of the word here of the word is, that usually means that. But again, usually. Let me show you the exception to that. Let's find one here. See right here where it says the sum is doubled. See how the word is, and I don't want to sound too much like an English teacher right now because I'm a math teacher, but I kind of have to when we talk about word problems. The word is part of a verb right there. In other words, it's part of an action. You know, like if you remember from your English class that they talk about verbs are actions, okay? The word is part of an action right there. It's the action of doubling the sum. If they say is followed by an action word, that usually means that the word is not referring to equal. It's just part of the action. Okay, so if they say is doubled, that doesn't mean equal doubled. Okay, the word is doesn't mean equal in that case. But if the word is not followed by an action, then usually the word is will mean equal. Okay, so see right here, the word is followed by the number 3. Yes, it has an action after that, but if it's immediately followed by a number, it usually means equal in that case. Usually. All right. Whereas here, that doesn't mean equal because it's followed by an action. Okay, is added. It's the act of adding something to the 3 here. 5 is the same thing here. That is not an equal sign. That is part of an action right there. Okay, but if you see right here, the result is the same as if. That sounds like equal, right? They're trying to tell you that something's equal there, isn't it? Equal to if the number is multiplied, and so the point is that they're trying to tell you that something is. Let me just go ahead and read the whole thing. If 5 is added to twice a number and this sum is multiplied by 4, that result is the same as if. So they're trying to tell you that the first part of the sentence is equal to the second part. All right. So just want to make sure that you're understanding the difference between when is part of an action versus when it means equal. Okay. What about here? The sum of two numbers is 20. Okay, it's immediately followed by a number that usually means it's equal to 20. Okay, let's go ahead and try some of these down here. Since they want you to write an equation right here, and since all equations have equal signs, you guys, the easiest thing to do when they ask you to translate a phrase to an equation is to find that equal sign. So let's read it. The quotient of a number in 4 is -1. Usually the word is means equal unless it's part of an action, right? So since it's immediately followed by a number, -1 right here, then the is should mean equal right there. Doesn't that? But let's just double check. Would it make sense to convert this to the quotient of a number in 4 equals -1? Yeah, that means the same thing, doesn't it? Saying is -1 is the same thing as saying equals to -1. All right, so let's translate this. What you do once you find your equal sign, you guys, is that it cuts the problem up into 2 parts. And each of the 2 parts is going to be one of these mathematical forms that we did on the previous sheet. And so we just have to convert each part the same way we did in the 2 previous sheets here in the earlier part of the video. So what you do is you take the first part and the second part, and you just convert it the same way we did earlier. The quotient of a number in 4. Quotient means division, and is where you put the division symbol. So that's going to be what? That's going to be x divided by 4. Again, we're using the word x or the letter x for the word number there. Then you put your equal sign where the word is located. And then -1, there's nothing that we already know how to translate that. You just write down the number -1. Okay, no confusion there. I'll let you guys try problems 2 and 3 in just a moment. Let's jump down to number 4 right now. Okay, and try that one. It says 1 added to 3 times a number. Is 3 less than 4 times a number? Okay. Again, the word is immediately followed by a number. That usually means that it's equal, right? All right. So, again, that cuts the problem up into 2 parts. Let's convert this the same way we did on the first 2 sheets. Let's convert this side over here on the other side of the word is. Let's convert that also just like we did earlier. Let's see how it comes out. 1 added 2. So what are we talking about here? We're talking about 1 plus what? 3 times a number. 1 plus 3x. So 1 plus, and you can bring it closer together here, but 1 plus 3x equals what? 3. Okay, here's that phrase lesson we got to watch out for, right? We got to watch out for that one. So 3 less than 4 times a number. How's that going to convert? Okay, remember you're not going to do 3 less than 4 first and then multiply after that, right? As we talked about, this is one of those ones where you have to do 3 less than this whole thing over here. So this is going to be what? It's going to be 4x minus 3 in the opposite order, right? Okay, you don't say 3 minus 4x. You got to say 4x minus 3 because less than tells us to do it in the opposite order. All right. Now, I'm just going to move over the 1 plus 3x right here so that it looks like a normal equation. It's not so far away on the page there. There we go. Okay. And again, you could have said 3x plus 1 as well. That would have been the same thing. Let me do one more here, and I'll let you guys do the rest. Let's do number 9, okay? If 4 is added to twice a number. Oh, hey, there's the word is again. But it's followed by what, you guys? It's followed by a action. Added means that they're in the act of adding something, right? Obviously. So is doesn't mean equal in that case. So let's keep going here. Try to find where the equal sign is. Since the problem says since the problem says to write the equation, we know that there's an equal sign somewhere here. Let's keep trying to find it because that'll break the problem up into 2 parts like the other problems. If 4 is added to twice a number and the sum is multiplied by 2, the result is the same as if the number is multiplied by 3 and 4 is added to the product. Isn't this where the equal sign is? Okay, if 4 is added to twice a number and the sum is multiplied by 2, the result is the same as, in other words, the result is equal to, right, as if the number is multiplied by 3 and 4 is added to the product. Okay, again, there's a lot of is words in this problem, isn't there? Is added, is multiplied, is the same as, is multiplied, is added to. All of those are actions except for this one. Is the same as, that's clearly saying that it's the same. It's equal. All right, so that's the one that's equal and not the other words that say the word is. This is the only is word that actually is a part of an equal sign here. And so we convert that to an equal sign right there. And then it breaks the problem up into 2 parts. The part that's before where it says that thing that I underlined. Let's convert that first. 4 plus what? 4 plus 2 times a number. Twice a number means 2 times a number, right? So we have 4 plus 2x. But notice what it says here. It says this sum. What sum? Well, they're talking about that since these 2 things are being added together, they're clearly talking about this sum right here. This entire sum is being what? Multiplied by 2. That's why you got to put a bracket around that sum. Whenever we multiply a sum or a difference by something, you've got to bracket that sum or difference. Okay, so the wording is a little bit different than it was earlier, but again, still the same idea. If you're multiplying a sum or difference by something, you got to bracket that sum or difference. And finally here, on the other side of the thing I underlined, it says what? It says the number is multiplied by 3, not the entire sum, but just the number. So that's going to be x times 3, same thing as 3x. And then it says, and 4 is added to that product. Product means multiplication, you guys. So they're clearly saying that 4 is being added to 3x. Because when they say product, they're talking about things being multiplied together. So they must be talking about 3 times x. So 4 is being added to 3x is what they're saying. So you could say 4 plus 3x, or you could say 3x plus 4. All right. Again, same thing because they both have the same sign. They're both positive, whether you say 4 plus 3x or 3x plus 4. Okay, so that is that one right there. Kind of a big one there. Please try the other 6 problems that I haven't done yet. Hit the play button, and then we'll wrap up this current portion of section 3.4. Okay, let's take a look at number 2 here. Where is the equal sign? Whenever you have the word is followed immediately by a number, okay, that typically means equal, so we can count on that word is meaning equal right there. We break the problem up again into 2 parts, with the is being in the middle there. I mean the equal sign being in the middle, because that's how equations are, right? The equal sign's always in the middle. So we have 7 less than a number. Again, less than means you reverse it around, so it's going to be x minus 7, not 7 minus x. And then 2, you just write down 2. There's nothing to convert there. All right, no words, just the number. Next one here, when 6 is added to a number, the result is 3. Again, this word is part of an action here, is added to, but this one is followed by a number, so this must be the equal sign right here. The result is, okay, the result is the same thing as saying is. When 6 is added to a number, the result is 3. That's like saying when 6 is added to a number, it's 3. Okay, you can shorten it. The point is that the result is just a bigger version of when you just say it is 3. Okay, so this whole thing means the equal sign is what I'm trying to say. So if they say the result is, or the result is the same as, okay, all of those things are just an equal sign, you guys. All right. So we got our equal sign. -3, nothing to convert there. It's just a number. And then 6 is added to a number. That's just like it looks. 6 plus x. And yes, you could also say x plus 6 because it means the same thing. And there you go. Number 5. If 5 times a number is added to 3 times a number, the result is, and there's that phrase again, the result is that must be the equal sign. There's only going to be one equal sign, so once you find something that you know is an equal sign, that must be it. Now, right after that, it says what? It says the sum. That's not an action, you guys. If it had said is summed, if they said the is summed, then that would be an action. But the sum, that's a noun. Again, pardon me for sounding like an English teacher, but I just want to make sure that there's no confusion here. Is the sum, all right? They're talking, the sum is actually a number, okay? We don't know what it is yet, but it is a actual number. When you add up 2 things, which is what a sum is, it's an actual number. So the is followed by a number here. It's just not an actual number like 3 or 5 where you can see it right in front of you. Okay, but that's not an action. Okay, like it would be if you said is summed. Okay, so you can be confident, therefore, that this is an equal sign. And let's go ahead and break the problem up into 2 parts again. If 5 times a number is added to 3 times a number, wouldn't that be 5x plus 3x? Like that? And yes, you could combine those like terms, but you don't have to do that until you actually solve the equation. They do not ask us to solve the equation here, though. You just have to write it. If you want to solve it, go ahead, but you don't have to. Okay. On the other side of the equal sign, we have the sum of 7 times the number and 9. So whenever they say sum, you look for that word and. That's where the plus goes. And so it's going to be 7 times x and then plus 9. Like that. Okay, a few more here. Here you can see the result is, and then it's followed by a number, so we can be confident that means equal. Is divided by, that's an action, so that's not the equal sign. Okay, so there's your equal sign. If twice a number is divided by 5, twice means 2 times, and we divide that whole thing by 5. Let me zoom in there a little bit for you. I know they kind of made that small. There we go. There we go. So 2x divided by 5, and then the other side is just the 4, right? Okay. Number 7. If 4 times a number is added to 8, the result is 3, and I think you're getting the point now. The result is, that is going to be your equal sign. It's followed by the number 3, so that makes sense. Break this problem up into 2 parts. It says if 4 times a number is added to 8, so that's 4 times x plus 8. 3 times the number added to 5. Okay. So 3 times the number and then plus 5. Okay. You could also say 5 plus 3x right there. Okay. Like we were talking about before. Finally, number 8. If 3 is added to a number and the sum is doubled, the result is 2 more than the number. Now, we haven't seen that phrase doubled before. Okay, I'm sure you've heard it a lot in real life probably, but not in this not in this class though. Mathematically, what does doubled mean, you guys? It means multiply by 2. If I double your salary and you're currently making $20, you're now making $40. Well, how did I get that number? Okay, I got it by multiplying 20 by 2. So when they say the sum is doubled, it means that the sum is being multiplied by 2. And as you guys know, when you multiply by the sum, you got to bracket the sum. What sum are they talking about, though? They're talking about 3 plus x right here, that sum. So 3 plus x, or x plus 3 is fine as well. But you got to bracket that sum and multiply it by 2, because that's what doubled means. On the other side of the equal sign, we have 2 more than the number. And there you go. Okay, so that is how to convert these sentences to equations, and that's going to be a big part of the second half of section 3.4, where we actually start seeing some bigger word problems coming up here. This is really going to help us with that, and it'll help us with some of the future sections as well. So please don't hesitate to let me know if you have any questions about any of this from this current video, so that you'll be better prepared for the next one. Okay, otherwise, have a great day, take care, and we'll see you back here next time.